Good afternoon to all. Any doubt in previous classes? No. Okay. Now we are going to discuss about one of the very famous and simplest topic. The relation between angular momentum and angular velocity. What? Relation between angular momentum and angular velocity. Okay, listen properly. Simplest topic this. Okay, listen. Angular momentum. Its magnitude simply denoted by capsule. Okay, then angular velocity is simply denoted by omega. Angular momentum and angular velocity or relation between angular momentum and angular velocity. Both are same meaning, no problem. Listen properly. Keep in mind, capsule means angular momentum, omega means angular velocity. Okay, that's all. Listen here. Simplest topic this. So listen properly. Nothing else. This is point mass. This is P vector, this is R vector, L vector, this is omega, angular velocity. Okay. Here, let us consider one rigid body. Already you have studied about a rigid body. Remember? Yeah. Let us consider here one rigid body rotating about its fixed axis. Okay. So here this line, that is the axis of the rotation. Okay, what is that? Axis of the rotation. Okay, so here let us consider one rigid body rotating about its fixed axis. Okay, then in your textbook, the rigid body, the diagram for rigid body given as different color. Okay, shadow. See that, no problem. Okay, then here, this is the point mass. What is this? Point mass. So the point mass of the rigid body is here at a distance r from the axis of the rotation. So when rotating rigid body, the point mass will execute in circular motion. That's all. Because rigid body contains lot of point masses. I am correct or not? Yeah. So the point mass is here at a distance r from the axis of the rotation. When rotating rigid body, point mass also will execute circular motion. That's all. Circular motion. Okay? Then, in circular motion, this is center, this is a radius or radius vector. Yeah. Let us consider here one body rotating like this in circular motion. Okay? How do you find out the direction of the linear velocity? Yeah. You draw one tangent line to any point of the circular path of the body. Okay? Drawing one tangent line to this point. Yeah, this gives direction of the linear velocity. Okay. At this point, like this, very good. At this point, yeah, very good, like this, B vector. At this point, will be like this, B vector. Okay. Then, what is the angle between B vector and R vector? What is R vector? Radius vector? No, yeah. Very good. Perpendicular to each other. Already discussed. In same unit. That means in first volume. Not same unit in first volume. I am correct or not? Yeah. Simplest concept. Here, very good. 90 degree. Here also 90 degree. Here also 90 degree. Here, yes, here also 90 degree. So always the angle between linear velocity and the radius vector compulsory perpendicular to each other, like this. Like this. Perpendicular to each other. So therefore, here, try a tangential line or tangent to any point in the circular motion of the rigid body. This line gives direction of the linear momentum. What will be direction of the linear momentum? Yeah, in the direction of the linear velocity, that's all. Okay, so P vector and R vector, or R vector and P vector. That means the angle between R vector and P vector compulsory, yeah. But, yes, you are correct. Perpendicular to each other. Angle, very good. Theta is equal to, very good. You are correct, 90 degree, that's all. Okay? So angle between R vector means here radius vector. So angle between R vector and P vector, 90 degree, perpendicular to each other. Then, when rotating in circular motion on of the body, how will you find out the direction of the angular velocity? What? Yes, very good. Suppose the body rotating like this. With the help of this rule, that means right hand rule. This fingers gives direction of the motion. Okay. This stretched thumb finger, yes, very good, gives us direction of the angular velocity through axis of the rotation. Yes. Suppose let us consider like this. Circular motion of the rigid body, like this. Okay, so angular velocity, like this. Direction of the angular velocity, omega. Through the axis of the rotation. I am correct or not? Yeah. This is the axis of the rotation. And also, direction of the angular momentum, yeah, same. Along with the angular direction of the angular velocity. So, L vector and omega vector both are same direction, and also along the axis of the rotation, like this. How do you find out this? With the help of right hand rule. That's all. This gives direction of the rotation of the rigid body. This finger gives direction of the angular velocity through axis of the rotation. That's all. Clear? Now, very simple. Here, okay, 90 degree, okay, then M means point mass, okay, this is angular velocity, this is angular momentum, okay, this is a linear momentum, okay, radius vector, okay, then the magnitude of angular momentum, yes, L is equal to, come on anybody, known persons, tell me, yes, L is equal to MVR sin theta, that's all, very good, simple formula. Theta is equal to 90 degree. So L vector like this. This is axis of the rotation. This is direction of the angular momentum. So L vector like this. R vector okay like this. R vector like this. This is P vector like this. Okay. So L vector is perpendicular to both R vector, very good, P vector, that's all. This pen, just assume that L vector, that means angular momentum. This is radius vector R. This is direction of the linear momentum, no, P vector. So L vector is perpendicular to both r vector and p vector. That's all. Okay. So therefore, here come here now. L is equal to mvr sin theta. Theta means angle between r vector and p vector. Already written in the board. Theta is equal to 90 degree. Sin 90, yeah. So L is equal to mvr into 1. So L is equal to mvr. Okay. Now, in circular motion, what is the relation between linear velocity and angular velocity? What? Very good. V is equal to r omega. V is equal to r omega. Correct. Substitute this relation in this formula. L is equal to m r omega into r. Okay. So L is equal to m r into r. Very good. R square into omega. That's all. In vector rotation, yes. In vector rotation, because angular momentum vector quantity, no? Yes, that. L vector is equal to m square omega. Okay. Very important formula. This is also very important. Okay, in this term, what is meant by mr square? What? Very good. Moment of inertia. Come on here. Moment of inertia of point mass. Very good. In the rigid body. Okay. Moment of inertia of point mass in the rigid body or in this rigid body. Okay. mr square means moment of inertia. What is the symbol for this? Yes. Very good. Caps I. But this rigid body made up of, yeah, so many point masses, no? Yes. So, what is the moment of inertia of the rigid body? Very good. Come here. Moment of inertia of the rigid body is equal to sum of moment of inertia of individual point masses in the rigid body. Okay. Therefore, I is equal to summation mi r square. That's all. Okay. Therefore, L vector is equal to summation of mi r square and omega vector. Sorry, not omega square, omega vector. So here, summation mi r whole square, sorry, summation mi r square, yeah, it is equal to I. Therefore, L vector is equal to I into omega vector. So, simply keep in your mind what is the relation between angular momentum and angular velocity. Yeah. L is equal to I omega. That's all. This is the relation between angular momentum and angular velocity. That's all. Clear? Okay. Next we are going to discuss about one of the relevant topic to the angular momentum and angular velocity. What is the relation between torque and angular momentum? What is the relation between torque and angular momentum? Okay, listen here. Now we are going to discuss about the relation between torque and angular momentum. Torque and angular momentum. Okay. What is torque? Yeah, tau. Angular momentum? Yeah, that's okay. What is, yeah, again consider this rigid body. What is meant by torque? Turning effect of body. Turning effect. In Tamil, thiruppu is turning effect of force. Turning effect of force. That is called a torque. Okay. Already here written L is equal to I omega, no? Yeah, considered to derive the famous equation for relation between torque and angular momentum. Okay, yeah. Come here. L is equal to I omega. L is equal to I omega. Okay. And already you have studied about the relation between torque and angular, yeah, acceleration. Angular acceleration. Tau is equal to I alpha. Okay. Here alpha means angular acceleration of the rigid body. Okay. What is the linear acceleration? Yeah. Rate of change of linear velocity or change in velocity with respect to time. That is called linear acceleration of the body. Angular means, yeah, comes here. Omega, that's all. So, alpha is equal to d omega by d. Rate of change of angular velocity, that's all. Am I correct? Yeah. Come here. Tau is equal to I alpha value d omega by dt. D omega by dt. So tau is equal to d into I omega by dt. Okay. So tau is equal to d by dt. What is I omega? Yeah, L. That's all. So torque on rigid body is equal to rate of change of angular momentum of the rigid body. That's all. Okay, then now we are going to discuss about one simplest concept, conservation of angular momentum. What? Conservation of angular momentum. Conservation of angular momentum. Already you have studied about the conservation of linear momentum. Yeah, similarly simple. This also conservation of angular momentum. Okay. Consider this expression or this term. In this term, if tau is equal to 0, if tau is equal to 0, it means, yeah, what? External torque on the body is equal to 0, correct. So, if in the external or in the absence of external torque on the rigid body, now you consider the condition is tau is equal to 0. So, if tau is equal to 0, dl by dt very good, 0. It means, yes, compulsory it will be, yeah, constant. So L is equal to, already you studied about this in mathematics, I am correct or not? So L is equal to constant. What is the meaning of this? Yeah, in the absence of external torque on the rigid body, angular momentum is conserved. Okay? Understand? Yes. Come here. See fully. Simple topic. This one of the simple topic. See full equations from starting to end. See that up to last. up to last. Read out? No. Okay, listen. Now we are going to discuss about one simplest problem relevant to angular acceleration. Okay, listen. Yeah, a rope is wound around a hollow cylinder. Listen here. Yeah, this is hollow cylinder. This is axis of the cylinder. Rope, no? Yeah, like this. Okay. Wounded very closely. Okay. Or simplest, we can draw like this. That's all. This is hollow cylinder. Okay. Yeah. This is two ends of the rope. This is axis of the hollow cylinder. Of mass 3 kg. So what is mass? M, no? Yeah. M is equal to 3 kg. Radius, yeah, 40 centimeter. So are no radius? Yeah. 40 centimeter. It is compulsory, you must convert it into, yeah, meter. So 40 into 10 power minus 2 meter. Centi means 10 power minus 2. Okay. What is the angular? Yeah. What is the angular acceleration of the cylinder? Yeah. Rope wound like this very closely. One end this is our other end. What is the angular acceleration? Like rotating like this. Angular acceleration if the cylinder, angular acceleration of the cylinder if the rope is pulled of a force 30 Newton. So applied force here 30 Newton. What will be the angular acceleration of the cylinder when we pulled with the help of applied force 30 Newton through rope? That's all. Clear? Yeah. Listen. M given, R also given. Yeah. Force. That means capital F is equal to 30 Newton. This is the data. Okay. Yeah. What is the basic formula for angular acceleration? Tau is equal to I. Very good. I alpha. Alpha means here angular acceleration. So alpha is equal to, we can do tau by, yeah, I. That's all. What is tau? Very good. Torque on the rigid body or torque, here torque on the cylinder, hollow cylinder. Formula for torque? Yeah. Tau is equal to F into D, general formula, but here D means, it's a radius. That's all. So F into R. That's all. I is equal to, you know that this, about this very well? Yeah, moment of inertia. That's all. So I is equal to M mass square. Okay? Yeah, substitute in this formula. Yes. So alpha is equal to tau by I, no? Tau, F into R, okay. For I, very good. M R square. Okay? Come on. R cancel out, plus remaining F by M R. That's all. Try yourself. What is the option? 0.25 radian per second square or 25 radian per second square or 5 meter per second square or 25 meter per second square. What is the unit? What is the meaning for meter per second square? Yeah, linear acceleration. That means the unit of linear acceleration. No need. Cancel. Yeah, this is the selecting method. Given options. In the given options. Compulsory does not come. Why? Here we want to calculate not acceleration, linear acceleration. We want to calculate, angular acceleration. So compulsory comes here. Radian per second square. So which option? In these two options only. That is the simplest method to selecting the options for 1 mark. That is an easy method. Leave it, strike out. Yeah, substitute. F value, very good, 30. By M value, how much? Yeah, 3. R, yeah, 40 centimeter. But you must convert to meter, no? So 40 into 10 power minus 2. Come on, try yourself. Anybody? You. That's all. Very good. Which option? First? No, that is wrong. You? Yes, very good. Second option. That's all. Come here. 30. Comes up, no? Yes. So 10 power 2. 120, that's all. Okay? So 30 into 10 power 2, you must add a double 0. Therefore, 3000 by 120. 0 0 cancel now. So 300 by 12, that is alpha. How much? 300 by 12. Yes, very good. 20 by radian by second square. This is alpha. So alpha is equal to 25 radian per second square. What is radian per second square? It is the unit for angular acceleration. So this is the, come on. Angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton. Clear?